This is lesson 6.4, guided notes continued, problems 3 through 6. Starting with number 3, we're dealing with interior and exterior angles here. So interior angles, the three angles inside of a triangle. Exterior angles would be outside. So again, that's the 132, and if we extended these lines, it would be those two angles on the outside. So interior angles and exterior angles have to add up to 180. The other relationship that is formed between exterior angles and interior angles is this right here. That you take an exterior angle, it is equal to the sum of the opposite interior angle. So not its own interior angle, but the other two. So we know that x and 62 has to equal 130. So the exterior angle is equal to the sum of the other two interior angles. So not its own interior, but the other two interior angles. So that's what they're asking us to put in right here, that x plus the 62 has to equal 132. Then just solve your equation. X plus 62, we want to get x by itself, so to get rid of plus 62, you subtract 62 from both sides. And again, it's giving you a little hint here. You got to subtract 62 from both sides. These 62s are canceled, and x will equal 70. And that's what they're asking us to solve for, is the variable x. So they're not asking us what is that interior angle, they're asking us what is x, so x would have to equal 70. So that angle where x is located would be 70 degrees. Other ways of attacking this problem is that you know that the interior and the exterior have to add up to 180. So if this angle, exterior angle, is 132, then its interior angle would be 180 minus 132, which would be 48. So we know that that has to be 48. And then we know that all three of the interior angles has to add up to 180. So x plus the 48 plus the 62 has to equal 180. So you go that route too to figure out what angle x is. But also want you to know that the two interior angles, their sum is equal to the opposite exterior angle. Let's look at guided practice number 4. So again, they're asking you to find the variables here. So in this case, they're asking us to solve for x. So we use, again, that knowledge that we look at the interior angles away from it, which are 70 and 41. And the only difference this time is that they've broken the exterior angle into two angles, the x and the 35. Well, both of them together are the exterior angle, so both of them together have to equal the 70 plus the 41. So that's what we'll write in there. We know that x plus the 35 has to equal 70 plus the 41. Again, the x and the 35 together are the exterior angle up there, and then it has to be equal to the sum of the opposite interior angles. So now we combine all of our like terms. X plus 35 will stay. We add the 70 plus the 41, and we get 111. Now we get the x by itself by getting rid of the 35. So x plus 35, to get rid of plus 35, we do the opposite, which is to subtract 35. Then you have the 111, subtract 35 from the right side as well, keeping our equal sign honest. 35's cancel, x is by itself, and 111 minus 35 is 76. So x has to be 76. And again, all kinds of ways that you can check your answer there. We know that this missing angle, we'll call it y, with these two has to equal 180. So y plus 70 plus 41 must equal 180. So y plus 111 equals 180. Subtract 111 from both sides. These will cancel. And y will equal 69. And then we know that the interior angle 69 and its exterior has to equal 180. So x plus 35, that's the exterior angle, plus the interior 69 has to equal 180. So combine our like terms here. X plus 104 equals 180. Subtract 104 from both sides. These cancel. And x will equal 76. So we get 76 again with double checking that way. Okay. Let's look at page 50. It's got guided practice number 5 and number 6 on page 50. All right. Number 5, triangle ABC is an isosceles triangle. Find the measures of angle 1 and angle 2. So again, earlier I mentioned that in the first video for 6.4, mentioned that isosceles triangles have two sides that are the same. And anytime you have a triangle with two sides are the same, then two angles must also be equal to each other. Now, that's what these markings here mean, is that those sides are the same. So the angle where those sides meet is not congruent, it's the odd angle out. So it's the other two angles down here where these two sides do not meet each other. It's those two angles that are going to be the same. So it's understanding that relationship that isosceles triangles have. Again, where those two lines meet right in here, that's the angle that's going to be the odd angle out. It's the other two angles that have to equal each other. So it says to find the measures of angle 1 and angle 2. So angle 1 is the exterior angle up there. Angle 2 is the exterior angle down there. Well, if we can find their interior angles, then we can figure out what those are because we know the interior plus the exterior has to equal 180. So look here, it says the measurement of an angle ACB, so ACB, that's this angle right here, is equal to ABC. ABC, it's that angle right there. So we know that that would be 75. So we can write that in there, that that angle is 75. And the measurement of angle 1 equals 75 plus 75. So here's your exterior angle. Remember, it is equal to the sum of the other interior angles. So again, not its own, but the other two. So both of them are 75. So angle 1 is 150. We have found that out now. So we know that angle 1 is 150. Again, we know that that angle down there is 75. Now it wants us to find the measurement of angle 2. So the measurement of angle 2 equals 180 minus 75. So again, here's angle 2, and its interior angle and itself have to add up to 180. So if we do 180 minus the 75, its interior, we should get that angle 2 measures 105. Okay, just take it again. Once we can find the interior, then we should be able to find the exterior because they're supplementary angles. Interior angles with its exterior is supplementary. All right, let's look at another problem here. Triangle EFG is isosceles. EF is parallel to HI. Find the value of X. So it's letting us know that EF is parallel to HI, and then that would make this line here a transversal, and it would make this line here also a transversal. So we have special relationships that are formed by those interior angles that you'll remember from 6.3 of our interior and exterior corresponding, alternate interior, alternate exterior, and corresponding angles. But let's see what we've got here with this drawing. So it says measurement of angle FEG is equal to IGJ. So FEG is right here, and that is equal to IGJ. IGJ is right there, and it's telling us that IGJ is 30 degrees. So if those two are equal, then FEG also has to be 30. So we could go ahead and write that in there, so we know that that angle there is 30 degrees. And again, it's isosceles. Here's your sides that are the same. So if that angle there is 30, we'll see in a minute what other angle also has to be 30. And as you see right here, FGE, which is this angle right here, FGE is equal to FEG, the one we just found to be 30. And again, that's because it's an isosceles triangle. Two sides are the same, so two angles need to be the same. So the angle where those sides meet is the oddball out. The other two are the ones that are equal to each other. So that means that FEG and FGE are both 30. And again, if you need to visually, put that in there. Now we're talking about the sum of the triangle, which we know the sum of the triangle has to be 180 degrees. So x plus 30 plus 30 must equal 180. Next step is to simplify, combine our like terms. We get x plus 60 equals 180. Now get the x by itself by getting rid of the plus 60. And the opposite of adding 60 is to subtract 60 from both sides. 180 minus the 60, and then x will equal 120. So we know that angle there must be 120 degrees. That's it for the guided practice for 6.4.